An introduction to radioactivity.
Some atoms have a very large nuclei. This makes them unstable. In order to become more stable, they emit radioactive radiation. This can be either alpha, beta, or gamma.
Alpha particles are made of 2 protons and 2 neutrons. It is the helium nucleus. An alpha particle is therefore positive. Its mass is 4 times the mass of a proton, therefore it is a heavy particle. It is very ionising, which we will explain later. The speed is about 10% of the speed of light. Alpha is absorbed by 5 centimetres of air or a piece of paper.
Beta particle is an electron. This also comes from the nucleus, which is a bit weird. It has a negative charge in a very small mass and travels at 90% of the speed of light. Absorbed by a metre of air and a thin sheet of aluminium. Because it's so small, it's not very ionising.
Gamma is an electromagnetic wave of high frequency, and it also comes from the nucleus, as all 3 radioactive radiation do. It has 0 mass and 0 charge. It travels at the speed of light, and it's the least ionising of the 3 because it has no mass. Because it has so much energy, it is very penetrating and can pass through, although it is decreased in intensity, by lead and concrete. This is the symbol for gamma. All 3, alpha, beta and gamma, cause ionisation. This is where, for example, an alpha particle collides with another atom. This could be an atom or a molecule, maybe a particle of air. When the alpha particle collides with the atom, it splits it into a positive ion and a negative ion, which is an electron that's been knocked off. The positive ion is basically the rest of the atom that was collided with minus the electron. As we said before, alpha is the most ionising because it's the heaviest, beta is the next most ionising, and gamma is not very ionising at all. Because both alpha and beta particles are charged, they are deflected, i.e. they will change direction when they enter a magnetic field. The alpha particle is positive and therefore will be attracted to the negative plate. After it's come out of the field, it will carry on in a straight line because there's no more force on it. The electron is negative and will therefore be attracted to the positive plate, and again, when it comes out of the electric field, it'll carry on in a straight line. Gamma is not charged and therefore is not affected by either an electric or a magnetic field. Background radiation is radioactive radiation that's around us all the time. This comes from mainly radon gas in the ground, trapped in granite, buildings and the ground. Of course, we dig up uranium, food and drink, because food and drink also is grown in the ground or stored in the ground. Cosmic rays, this means rays coming from other galaxies and stars in the universe. And then also a certain amount from artificial sources, so nuclear power, the remnants of nuclear weapons, and medical sources used in hospitals to treat and diagnose diseases like cancer. Background radiation is always there, and so whenever we actually measure a source of radioactive radiation, we have to eliminate the background radiation, and we'll show how to do that in a later video. So to summarise, all 3 radioactive radiation, alpha, beta and gamma, all come from the nucleus. Alpha particle, 2 protons and 2 neutrons, come from the nucleus. Beta particles, an electron, strangely coming from the nucleus because electrons don't normally live there. And gamma, an electromagnetic wave, coming from the nucleus. Woo!